Let's discuss new problem. Move all zeros to end of an array. Means we have an array and there are in between zeros and we have to move all those zeros at the end of the array without disturbing the sequence of that array. That is our task. So in front of you there is one array 1 2 0 0 3 0 and index from 0 to 5. So in this video I will be going to discuss two solutions. One is by using naive solution, take time complexity of big of n square, and second is a efficient way, a better solution which can uh, reduce the time complexity and it takes big of n time complexity. So just proceed with this naive solution. So as you see that big of n square means for sure we require two for loops. That's why it is going to be taken big of n square time. So what will be the logic for naive solution? It is simple that we first take first element and we check that if it is 0. If it is not, then not equal to 0 means move on. And likewise I is equal to 1, we have iteratively go through the array like I0, I1, I2, I3 and so on. And when we found that the 0 present in that particular index, then we just swap the element of that j and I. Means when we found that array of 2 is 0, then we initiate another loop which is start from the I plus 1 index, means forward to that index, next proceeding to that index, and we have to just go through the array again inside the loop, and we have to compare that if there is any non-zero element present in that particular array. If that possible, then we just swap non-zero element with zero element, and which taking care that we cannot disturb the sequence in which they are occurring. For example, after 2 0 are there and after 2 0 there is a 3. So after swapping the element, 3 should be after the 2 and 0 at the end. So likewise we have to uh, do like this way. So in next iteration, if array of 3 is 0 again, if j is equal to 4, then array of 4 is 0. Okay, then move on because both the array of 4 and array of 3 both are zeros. So we don't need to swap them. They are just in their own position. And after that, when we go forward and let's say check array of 4, which is I'm not written here, and if it is 0 again, and we initiate another loop which is jth loop, and that jth loop again traverse I plus 1 to nth index, and it checks that if array of j is equal to 0, then it is again move on. If it is not equal to 0, then we swap the elements. So this is simple logic, and after all at last we get this array 1 2 3 0 0. So let's try to code it. We require two parameters, array and number of elements present in that array. So as I had already gone through the dry run of that code, sorry. So I have to just code it likewise. So if array of I equal to 0, that means we have to initiate for loop. If it is not equal to 0, then we can't we here not write a else condition. That means we just move on without doing anything. And if array of I is 0, that means we have to swap that element. Array of j is equal to I plus 1, j less than n, and j plus plus. And again we have to check while iteratively go through the jth loop, we have to compare that array of j is not equal to 0. If these two conditions satisfy, then we just swap the array of I and the array of j. That's it. This is code. First we gone through the every element. If we found that it is zero element, then we start another loop, which is j is equal to I plus 1 to n, and we compare that. If it is not equal to 0, we just swap that. So this is taking time big of n square, because in upper loop, which is outer loop, it takes n time complexity, and for each I 0 to n, for each one index that I, the inner loop will take n time. So 1 into n, 2 into n, likewise n into n, that is n square. So n square time complexity is taken by this solution. So just check. After that, we have to take that array elements. After that, we have to call the zero end function. After that, we have to print that array. So running the code. So okay, enter the number of elements. So number of elements is 6. So 1, 2, 0, 0, 0, 3. So as you see on the screen, the all the zeros which are in between the numbers are coming at the end. So that's it. Our big of n square time complexity is running better. So let's move on to the efficient solution, which is takes time big of n. So what could be the logic? Like we have to just use one for loop instead of two, which makes our life easy. We have to use one for loop. So there must be something which taken into consideration, that because of that the number of time we have to iteratively go through the loop or that array is going to be decreased. So we have to think like what could be the solution. So in this case we have to take an extra variable, that is count. I'll tell you what is the variable and how we will work according to that variable. So first we require one loop, because without going through that array elements we cannot figure it out that whether the elements are zeros and ones and whether they are non-zeros. So likewise I is equal to 0, So initially I declare a count variable as a 0. I check that if array of 0 is 1 in for loop, because I is 0 means for loop is initiated. So array of 0 is 1 means it is a non-zero element. So we just simply swap array of 0 and array of count. So what is a count? Count is 0. Means we swap the element 1 by itself. Means 1 is in its original position. After that, afterwards, we just increment the count is equal to count plus 1. So count is increasing. I is equal to 1. Now count is 1. So array of 1 is 2. So again it is non-zero. If it is a non-zero, we again swap array of 1 to array of 1 only, because it is non-zero. So we're taking consideration that we don't want to swap the elements which are a non-zero. We have to swap the elements which are 0 with the non-zero, like we did in first iterative go, in first naive solution. So when I is equal to 2, count is equal to 2 because count is incremented. So array of 0 is 2. Array of 2 is 0. So when we found 0, we have to move on. So in first solution, when we found that element is 0, we actually go into the for loop. And that's how the time complexity increase in that particular solution, previous solution. But in this case, we think reversively. Like when we found non-zero, we swap. When we found 0, we move on. In first condition, in